Hi, everyone. So today's discussion is going to be Git. I'm going to be going over sort of the mental model that I like to have in my mind when I'm working with Git. I'm not going to try and sell you on reversion control, although that's sort of what this PhD comic is. But rather, I want to try to get you to the point where you can comfortably use Git. Git is one of the pieces of software that's supported by SHARCNet. There's other version control systems. We support them as well. Internally, though, one of our sysadmins has set up a Git server for us to use and for our users to use as well. So it has a nice feature there with a bit of integration into SHARCNet. So, and I'm going to do this presentation in a bit of a different style here. So hopefully this will work out. I'm going to slow things down a bit and bring in some of what would be sort of Blackboard style. So I'm going to construct my images here on this side, and then I'm going to be doing a live demo at the same time on the other side. So now, what is the Git? Git basically consists of 3 components. Well, 4 components, depending how you want to categorize them. But let's just start with 3. And the very first thing it has in it is what they would call the Git database. And Git, they call that their database the object store. So I'll just put that here. So that's the object store. And the object store is a database. It's where your Git objects are stored. The objects consist of your commits, basically all the versions of your file. So that's the first component to Git. Now the second component to Git is what they call the index. This is something that's a little bit different between Git and other version control systems. So Git has something they call the index, and basically that's where you put together your next version of your code or software, whatever that you are wanting to save. And it's also known as staging. And then the final component that you see in Git is just your directory. And that's where you work with your files. So that'll be your folder or your directory or whatever you want to call it. It's also known sometimes as the working tree, is some of the ways you'll see it referred to. And the essence of Git is basically just moving stuff between these things. So where we start is we start with our folder and we put together the next version of our software. So that allows us to move stuff in this direction. And then once we've assembled the next version of our software, then we do a commit, which takes it from here and puts it into the database. And that's the essence of Git. Now, Git is also what's known as a distributed version control system. So unlike something like Subversion, which has some centralized server, each Git repository contains all its own information in the object store, the database. But they're peer-to-peer, so they can work together. So you also have what would be called, for lack of a better word, remotes, which is just other peers out there of Git repositories. And these just sort of, if you will, live in the cloud. So that can be other machines on the internet, that can be just other directories on your own, that can be systems like GitHub, services provided by other companies, can be basically anything identifiable by a URL that provides access to object stores Git object stores stored elsewhere. All right. I don't actually want these arrows in here for my demo here, so I'll just get rid of those two. So this is sort of our, this is what we're working with. This is the Git world, and we're moving stuff between it. So as a demonstration of setting this up, we're going to create a simple example hello world program, and hopefully we'll get far enough too that we can bring in SHARCNet's remote servers as examples as well. So let's say we're going to make a hello world program. So I'm going to just make a directory on my computer here, hello world. I'll switch into that directory. There we go. And I want to create my Git setup. So the very first Git command, it's good to know, is the init. The Git init command initializes the Git repository. So currently I just have my folder, my directory, right? Git has the object store and index, so when I run Git init, it creates them. And it puts all that stuff, because as I said, it's an entire version control system, and each directory that you use it just shoves that all under the .git directory. And if you want, you can go into the .git directory and have a look at the files. And some of these you can edit, like a description of your project. The config file is just sort of a standard, if I cut that out, it's just sort of a standard key value pair broken up into categories. So let's talk actually a bit about the configuration, because one of the things Git does is it stores the revisions and the edits and stuff made, so we have to have a way of identifying who made them. So one of the key things you want to do when you set up your Git repository is you want to set your, tell it who you are. So you want to do a git config, or you can edit the config file if you prefer. Now, if I specify the global option, that edits the tilde.git config file, and that applies to all Git repos. If I don't specify the global option, then it just sets it in this config file in the Git directory, so it just applies to this particular Git repo. But if it's my username, I want to set it globally. So I'll set my username Tyson Whitehead. I quote it because it's got a space in there. And I will set my email, user.email, to my email address. And this is just, if you don't set these, when you first go to make your commit, it'll complain and tell you have to set them so it can associate them with the user. And then another good one that's useful to set is to turn on the color feedback. Git has color built into a bunch of its commands, so it's nice to be able to see those. So again, there, I've enabled the color. And as I said, all this just actually went into a .git config file under my home directory. And you can see it's pretty easy to edit it by hand as well. And if you're looking for help on this, the Git commands are all Git verb, and you can look them up in the man pages. So man git config will bring up the manual page on any of our systems describing it. Or you can just simply Google git config, and the main Git site has pleasantly converted all these names into man pages on the website as well. All right, so here we are. So let's create, so now so far what I've done is I've got an index and a staging and an object store, but there's nothing in them, right? That's nothing in my home directory either. So let's create my hello world program. I'm just going to use Python. Why not? Put that up there. Put that back to my terminal. Okay, so a basic hello world program in Python. Pretty easy. Print hello world and verify that it actually works. So Python, hello Py, hello world, excellent. So now, if we want to go over to our Git picture over on this side here, we now have, just zoom in here, we now have a file under my folder. We'll add that in here. So hello.py. All right, and this is our initial version of our program, so we want to put together the first version. And this might seem kind of silly when you just have a single file, but in the event that you have many files, it actually makes sense to be able to pick and choose the bits you want. You can have several things in flight at once, several features or whatever you're working on. Put them together, stage the next version. So let's stage our next version here. I will use the color green here to indicate adding stuff. So the first thing we're going to do here is we're going to go like this, and then the git command to do it is just simply add. And in more details, it's actually add path, so I specify which file I want. And it's very useful to know there's a -p option, which does a patch, so it'll actually show you each bit of that file that's not already in the index and ask you, do you want to add this? Do you want to add this? And then the other thing you want to do, sometimes you've removed the file here and you want to get it out of here. So then the other command is to remove. And again, that's just a path. So going back over here, let's add this in. So we'll do the git add hello.py. All right. So now after having ran that command, if we go look at our diagram over here, we have now moved hello.py, well, copied hello.py up into here. So let's add that on there. I'll just put it in the black color here. Hello.py now shows up in here. And we can ask Git, one of the very useful commands is git status, shows us where we are. So it says we're on the master branch. We'll get into that later. These are branches can be named whatever. Master is the default. We're on the first commit. We're working on our first commit. And so far, changes to be committed, we've staged hello.py. So this means we've got a new file and it's in the index. It's green. It's going to go into the commit. Now, let's do the actual commit now. So in the actual commit, we're going to take this here and we're going to basically take the sum of the index and we're going to move it into the object store as the very first version of the program. So it's pretty basic. We just go like this. Here we take this whole, just a better job at drawing that line. This, and then the command to do that is simply enough, just commit. All right, so let's do that down here. Git commit. Oh, sorry, just to let me change my editor so it opens it inside my existing Emacs section. You can set your editor to whatever you want. Okay, I'm not going to bother with that. So it brings up your editor. In this case, my editor is VI, and you can put a description. So I'm going to say, Hello World example program for teaching Git as a description. Now, just a quick comment on descriptions. In the Git world, you want to have a sort of summary as your first line, and then you can add additional details down here that you think are relevant. And the reason is because lots of items will just show you the first line. If you're looking your way through a whole bunch of them, it's very nice to just be able to see the summary line. And the summary line should not be a description of what the change is, because they can use the git difference command to see what physical change you actually made to the file. But why you made it, like if you fixed a bug, the fact that it fixes the bug, implemented a new feature, what the feature was. In this case, we're not going to basically have any sort of additional descriptions because this is a pretty simple thing here. So we'll save this file. And there, Git has now created the first version. So what that means is if we go over to the object store here, down in the bottom of the object store, we'll just zoom in a bit. I can draw this in here. We now have an initial version of the program. So we will put that in blue, just down here. and that's it. So I'm just going to put in a description for us so we can kind of keep track where we are here. So this is the initial version. Now, associated with the version, there's a couple of terms. This is where branches come in. So first term you have to know is there's something called head. What is head? Head is, if you want, it's just where we are in here. We're going to build up a tree structure, I guess, of versions, and head is the one where we are in that tree structure. And then because it's not very nice, we need something to refer to them by. There's also a reference name, and in this case, we've just got the default master. Now, normally these reference names would be chosen to have some relevant, like there might be version 1, might be some showing up in our tree history, version 2. When you first start working on a project, though, it assigns master sort of as in the master version where you're working with. And you can also tag them with names as well. There's a git tag command. And that's like release 1, release 2, something you want to remember. Anyway, so let's run the git status command here again. On branch master, nothing to commit, working directory clean. Let's have a look at the log here. And we can see now that this takes us from where we are currently. So master going backwards displays all the commit messages. And as I said, lots of times you don't actually want to see the sort of details. So you can do the one-line log, which gives you a nice compact. This big ugly number is a unique identifier that's been assigned to this commit, and I can refer to it by this unique identifier or by the first 5 letters, or however many letters this is, 7 letters, I guess, as a short form, because it's kind of a pain to type these things in. All right. So let's actually build up a little more of our commit here so we can see some more. So let's say we decide to, modularize our code. It's kind of sort of one big monolithic application, so we're going to break it up into some functions. So we'll add a greet function here, or Python, and then the main body of the code we'll just call the greet routine. Okay, I mean, again, this is kind of ridiculous for this particular example, but it serves as an example and allows us to make some additional commits here. So let's have a look at our status again now. Now, Emacs, my editor, is saving a backup file, so that's why it's showing this hello.py tilde file, and it's saying it's untracked. So that's something Git doesn't know anything about. So if there's files that show up in your directory that Git hasn't been informed with, they haven't been added, then they will show up like this. Now, the ones that exist in the Git repository, because I've already added them, is giving me their status. So it's saying, oh, you've modified the hello.py as my status, and that's in red. If you remember right, when it showed it before, zoom out here a little bit, between the index and the staging, it said it was green. That was, it was ready to be committed. And between the folder directory and the index, it's in red, saying that it's not going to be included in the next version. Let me just correct the color on that. I always forget to unselect. All right. So how do we see what is going to be, what changes I've made? So one of these useful information commands is the git diff command. And git diff basically lets you do comparisons between these various parts. So all of Git really works is moving stuff between these parts and comparing them and basically seeing where things are at. So we've got an arc here, like this. And basically, we can do a diff command. And the diff, if we don't specify anything, it'll show us all the differences, or we can be more detailed, and optionally, that's what the square brackets mean. The angled brackets mean you substitute in an actual real value. We can specify a path. So let's give this a try. Git diff, it shows me what I've changed here. And actually, I see I've got extraneous extra line on the end of the file, so I'll get rid of that. I can get diff again here. So I've removed the hello world, and I've added the function greet and the call to greet. So that's showing the difference between this hello pie and that hello pie. So with that said, let's go ahead and add this one in. So we're going to stage up our next version here. So we push the new version up into the index, and if we ask for the status here again, you can see now it's changes to be committed. It's green. It's going to go into the next version. There's no changes that I've made that aren't going to go in the next version. And then I've got this untracked file as well, which I don't really care about. That's just Emacs's backup file. And if I ask for the difference, now it's not actually showing any differences. So let's zoom back out on our diagram here again. Scroll around. One of the things you'll want to see very quickly is what exactly am I going to commit? In other words, how do I look at the difference between the index and the object store? So again, that's another diff statement. Let me pick a color here. There we go. So I'm using green to represent adding things, and I'm going to be using red eventually here to represent possibly stuff coming the other way destructively, and blue as information. Okay, so we want to compare these. So the command again is still diff. And if we want to compare these two ones here, then in this case, what we want is diff and minus index or cached. They got typical Git, there's a gazillion ways. And then again, if we want, we can specify an individual file, or if we don't specify an individual file, it'll just show all the files. So let's give that a try. So get diff index. Staged. So I'll just fix that there. Staged. And again, optionally, you can specify a file path if you want to compare that as well. All right. And so this is basically showing me what I have staged to commit. And again, I only have one file, so it's only showing me the one file. But I could also, if I had more than one files, I can tell it exactly which file I want. So there, I've specified a file name. So say we're happy with this commit, so let's throw this into our thing as well. And so we'll commit that. Again, we have to enter a commit message. So I guess the fact that we've modularized code by breaking it up into functions might be a good description. There we go. And let's ask Git to see our log. Now we can see we have the 2 commits. And in fact, this is here you can start seeing how the one-line option on the log is kind of nice. And you can actually add a graph option as well, which will show the graph history. So it's actually, as we get more details here, you'll see it's actually drawing little lines between these stars to show where the various versions come through. So let's update our picture here again of our object store. So what we've done here now is we've created a new version. Oops, I guess I was using the dark blue. Created a new version here. This version came from the previous version. And in this case, we've broken it up into functions. So let's just put that here so we can remind ourselves where we are at. functions. And now this is sort of where things get interesting, because Git here, when we did a commit, it automatically moves our information about where we are. So head and master get moved up to the new version. So you can see here how we start constructing up a version. Okay. And now that we have two versions, there's actually, we can use yet another different form of the diff option. So I will write that up here. At the top, we have the option of using a diff. Okay, well, first of all, a diff between a version and the folder. So we can have a line here basically coming across the bottom to do our comparisons this way. And in this case, how we would refer to them is we would say, would be the diff command again. And in this case, we would give it a commit. And then optionally, again, a particular path we want to look at. So that could be like a file name, a directory. So let's try this here. So say we want to see the difference between this version here. So we'll take its identifier, just cut and pasted it in there, and my current hello.py. Now it says, okay, well, from the first version to the one that's in your directory, this is the difference. Okay. So let's say at this point here, we've decided, we'd really like to add some interesting functionality on this. We're going to make this Hello World program multiprocessor. We're going to add some MPI functionality. But we think this is going to maybe take some work, and we're not sure how successful we're going to be. So we don't want to mess up our work, what we're doing here. So we want to keep this simple version that we've built up nicely. We've modularized it. We want to keep that around. And then we also, on the side, we want to work away on this MPI version. So how can we do that? Well, the answer to that is Git branches. And so what we're going to do here is we're going to go off to the side and we're going to work away on the MPI version, and then maybe off on this side here we're going to continue maybe adding regular features to our simple version, and then maybe at some point we'll bring them back together into a single version. So let's create a new branch for working on the MPI stuff, and the command to do that is simply git branch. Well, if you run git branch by itself, it'll display all your branches. Currently, I only have one master, and the star indicates that I'm on it. But let's add a new branch. Let's add the MPI branch. Let's have a look at it. And you can see I'm on the master branch, and there's also an MPI branch. So what has this command done? Well, basically, it's created another name. So we'll add that in here. So we now have an MPI. And I'll add the command up here as well, just so we can keep track of it. So again, it's branch to display your branch. And optionally, you can give it a -a, which will display all branches. By default, if it knows about remote branches, it won't show it. It just shows your local stuff. So -a will tell it to show the remote branches as well, which is useful because lots of times you want to work with them. Now, the command to add a new branch, so we will put that in our green, is simply branch and then a name. which creates a new branch right there. And you can actually optionally specify a commit to make it from as well if you want. Sometimes you want to spin off a new branch that's not from wherever head is. All right, so now we want to leave the master branch alone, and we want to go over and work away on this MPI branch, which brings us to our next command, which is a git checkout command. So currently, we are associated with head is tied to master. What we want to do, head, you can kind of think of head as like a little star marking where we are. We want to tie head to MPI and go away and work on MPI, and master will just be left here by itself. So let us put in a thing for that. So now this is going to be red because it actually will, in this case here, all our points are at the same point. Head, master, and MPI are at the same thing. So as we switch around between them, it doesn't make any difference. But if we were on master and MPI is over here, when we run the checkout, it's going to bump us over to here, and it's going to update our index and our folder to follow that switch over. So that's a potentially destructive operation. So we'll put it here. Some big arrows here to indicate. There we go. And the command is checkout. And you give it a commit to checkout, which is generally just the name of a branch, but it doesn't have to be. Could be the name of a tag. It could be just one of those version numbers. And there's also, as you want, I'll mention this here. Just for completeness, you can also pull a file out of a previous version. So the general checkout command bumps your head to be the commit you specified and updates everything. But sometimes you want to just check out a particular version of a file in here. So there's also a checkout command where you can specify a commit and then a path, and that just goes and extracts the file from that particular version. And let's give it a quick example of this here, right? So right now we have the hello.py from our latest version. Say we wanted to go and pull hello.py from, well, let's get our log messages up here again. One line, the graph. So say we want to go pull the hello.py from this version here, hello.py. All right, so reload our hello.py file, and you can see I'm back to my original one. So I've yanked that particular file out of here into my folder, and I've also yanked it into my index, which means that if I ask git status is going to say you've got changes to be committed. So you've got this hello py here, and it's ready to be changed. Now it's giving me another thing here too. This is a bit of a diversion here. Git reset head to unstage. So what does git reset do? Git reset lets you just bring stuff from your object store into your index. So if I want, I can bring the current version of hello.py from my current version into the index, and I'll have effectively unstaged that check to be committed. So let's add that to our diagram here as well as another command. If we want, we can go from here to here, and the command for just doing that is reset. And again, it comes in two variants. You can do a reset to a commit, in which case you're doing all the files, and you're also moving your branch down. So for example, if I reset master back to here, it would, master being where my current head is, it'll bring me and master back to here. So I can, that way I can throw away a commit. Say I've made a commit and I'm like, oh, I didn't want that. I can just use the git reset command, which will back up to a previous version. I can just look at the log and pick out whichever version I want. Or if you, again, if you want to just bring a particular file, then you can do the reset commit and path. So in our case, let us reset this. You know, I checked out the first version of this file. I really didn't want to have checked out the first version of this file. So let us reset that back. So git reset hello.py. There we go, git status, and you can see it's no longer set to be committed, but it's saying I've modified it still. And the reason is because reset just updated the index, right? So the checkout is still affecting my folder. If I ask the difference between my folder and the index, you can see my folder has the original, just print hello world, whereas the index has the new version. So the final command here to complete our moving of stuff around is how do you bring stuff from your index back into your folder? And that's the checkout command, another variant of the checkout command. So in this case, we're coming, whoops, let me zoom out a bit there, make that line a little thicker. So we're coming down from here to here, and the command to do that is checkout, and you specify a path. So we brought back in our original hello py into the index, and let's finally bring it back into our folder as a complete demonstration of how you can move stuff around. Now if we run the status, we're back to normal. I reload the file in my editor here. It's changed on disk, that's right. We can see we're back to the original version. So that is the basics of moving your files around in Git. So again, you can add it, remove it, so set up your next version, commit your next version, and then if you want to jump to a particular version here, you can use the checkout. You want to undo a result of adding, you can reset your index back to the way it was originally, so that's the reset command coming that way. And then you can run these diff commands here to look at the differences between the various parts. All right, so with all that said, let us create our MPI version. So we've created this MPI one here. We want to switch to the MPI branch, the MPI version. So we want to do a git checkout MPI, switch to branch MPI. We do a status. It says now I'm on branch MPI. Nothing's really changed though because master and MPI at this point are the same. If I run the git branch command, it's going to show I've got two branches. The branch I'm currently on is the MPI. All right, so let's code up this function here. Let's reload it, make sure I've got, yeah. So we're going to import the MPI for Python libraries. The MPI module is MPI. And then we're going to maybe call our rank here. So that'll be MPI. We'll access the com world communicator, and we'll call the get rank function on it. And just cut and paste that. Same for the size. So an MPI world size is the number of processes. Rank is your process number. So I'll change our message to hello world from process. Put in the process number of, put in the other process number, call the format string to supply the options. This is just sort of bog standard Python. So perhaps a bit confusing if you're not familiar with Python, but this is very close to a printf line in C. So this will be, you know, like %s, and then these are the two arguments to fill in for those. All right, so let's make sure this works here. And now I'm just going to quickly check something here. Excellent. So let's run this, MPI run, number of processes, let's try 4, Python, and our program hello.py. All right, excellent. So we got a basic MPI program put together. So let's commit this. Hello.py. We're going to commit it, and we'll add multiprocessor support via MPI as our commit message. Okay. Now, what has this done in our picture of where we're at here? Let's zoom in here a bit. We've created another version. Here, so that much is, get my focus here. There we go. So we have yet another version here, and this is the MPI version. It's pretty clear it came from there. And now head, of course, indicates the current version I'm actually working on with the rest of the stuff. So head has moved up. MPI was the branch I'm on, so it's moved up. Master is left down there. A little marker in so we can. So now this is what our system looks like. And now we have two branches. We have the MPI branch and the master branch. So we can continue working along on this MPI version, or if we want, we can jump back to the master version. So let's say, oh, you know, someone's pointed out some sort of issue with master. We want to go do some work back on that version, so the non-MPI version. We just run git checkout master, switch to branch master. So the checkout command here, if you recall right, that'll have updated my index and my folder. Let's give this a try. We'll reload the hello.py file, and sure enough, we're back to the pre-MPI version. And we can work away on it. If I run the git status, it's updated my index as well, so this has the pre-MPI version. And then at some point, you know, we want to go work away on the MPI version, we can just switch over back to the MPI version, check back out the MPI branch. Let's reload this hello.py. Yes, and there's our MPI version. So Git's very powerful in that one of the big features in Git that it does very well is branching. And you're going to write a new feature, create a branch, do the work in there. You know, if something goes horribly wrong, you can just throw it away. And then when you're done, you can bring the two together. So let's bring us up to our next point here. And we're going to add what we would call a remote. So we're going to let Git know about another Git repository. And in this particular case, the Git repository we're going to let Git know about here, if I can bring this along, is the SHARCNet GitLab server. So if you go to git.sharcnet.ca, just in your browser here, you'll bring up the SHARCNet GitLab server. And you just log in. It's your standard SHARCNet username and password. There we go. And it'll bring you up to your projects page. And I'm involved in a variety of projects here. Probably, if you're a first-time user, your projects page will be a lot simpler. So you go into your profile settings. You can upload a little gravatar of your face there. Update your email, whether you want your email shown. You can set up multiple emails here. In this case, you can see I've added my Gmail one, and that's because that's the one I've actually configured Git to record my changes as. So if GitLab knows about that, then it can show whenever it sees the author was twhitehead@gmail, it can associate it with my GitLab account. If you've got an SSH key or you know how to use SSH, you can add SSH keys here, which lets you authenticate with an SSH key against the GitLab server for submitting changes from it. So that's nice to have as well. And I think that's about all I actually wanted to show you from the profile page. So, and you can also explore here and you can have a look at the various projects other people have that either you're a member of or they have marked as public. So let me go back to my projects here. The dashboard, that's right. You click here to bring you back to your main part. So let's create a new project. We're going to call it Hello. And it's going to be, you can import it from, GitLab or lots of these common ones. So demo Hello World program for showing off Git is my sort of description. Now this is the big thing that this server adds over something like GitHub is you have the option of making it a private project. If you want to do that with GitHub, you'll have to pay for Git Setup. You get a monthly fee for that. In this case, I just want a standard public project. So we'll create the project. There we go. Project Hello was successfully created. And then it's given me some command lines. We've already seen this. Configure your username, your email. It's recommending my SHARCNet one, but because I've added my other one, it'll know who that's from too. It's giving you the command to clone a repo. We'll be going over that command shortly. Basically telling you to add a README markdown file into an existing Git repo. So this is if you're creating a new repository. This is if you have your code currently in a folder and you want to put it into Git. So switch into the folder, run init, tell Git about the GitLab SHARCNet server, add your stuff, commit it, and then push it up to the GitLab server. We'll be going over those commands shortly. I just wanted to show you this here, settings. So you can change your visibility level here, you can archive it, rename it, transfer it to a different user, or remove the project. So that's good to know. And if you've added users to your project as well, you can set what branches they're allowed to push to. So you could say, okay, this user is allowed to, like if I had a bunch of students, I could have one directory called, say, Susan, if Susan was one of my students, and I could say Susan can submit her changes to the Susan branch, but I don't want her doing anything on the Tyson branch because that's my branch. If you want to add your students or other members, you can do it through this page here, and then you can give them permission. So say, add members, people, let's say I wanted to add the first SHARCNet Lab account, project access, a couple different levels there. Say as a developer, add user to project. So then that will give this lab member rights to push to my account to update this repo as well. All right, so anyways, that's basically how you set it up. So now we have this remote system here. Let's go back up here. Let's tell our Git system about it. So what we want is git remote add. And we want the URL here. So the SSH URL if you've set it up with Secure Shell. Otherwise, you have to use the HTTPS. HTTPS is a bit more painful because you have to keep typing in your password, but less SSH setup required. So you just give it the URL and you give it a name. The default name is Origin, so I'm going to use that, but it's perfectly okay to give it a better name like SHARCNet or SHARCNet Git or something like that. All right. So now my Git system knows about a remote. So let's add that into my diagram. But now we have a remote one here, Origin. And that's basically just one of these databases, Git databases, up in the cloud. And you can add as many of these in as you want, because it's a true peer-to-peer version control system. All right. And the command to add those again here, I'll just add the command in along the bottom here, is remote add, and then it is just some name you want to assign it, and some URL. And if you want to get rid of it there, you can also do a remote. You put that one in red. Remote. I believe it's RM in the name. Okay, now what we want to do is we want to take my current work here and we want to move it up into this remote repository. And now we want to, the one we want to remove though, the MPI stuff, I'm still working on that. So let's just put the master branch is all we want to sort of expose to other people, the world. Remember, this was a wide open project here. So my next command we're going to do, the last kind of bits of data flow we have yet to show you, are pushing between the local object stores and the remote object stores. So in this case here, these are non-destructive because you can use it to add stuff in on the remote end or on the user local end. So we're going to going this way, and of course the other way you can also bring stuff going this way as well. We'll get around to that command shortly. Okay, and the command to add this here is push. Push, and then we want to say the remote we want to push it to. So again, that's just the name. I guess I should have consistently called that remote there. And the branch we want to push. All right, so let's do this. We want to push up my master branch. So we'll just say git push. Origin was the name I gave the SHARCNet git serve. And we want to push the master branch. And now, because I'm not using SSH, I have to enter my SHARCNet username and my SHARCNet password. So I can do this over SSH, HTTPS. And there, so it says it's sent a new branch to the remote side, master to master. And if we go back to the GitLab server here, refresh the page. Now there's stuff there, so it's just saying if you had a README file, if you add a README file, you can do it up in Markdown. It shows it here, so it's a nice way to add a little summary to your page. Let's go have a look at the files. Okay, so here we can pick which branch we're on. I've only pushed the master branch, so that's all you can see here. We have the hello Pi. It was last updated 30 minutes ago. Here's my comment. I can click on it. I can view it. I can view the history of it. In this case, there's just 2 commits that have changed it. I can run the blame here, which tells me who created each line of the file, when it was created. If I want to just download the file, I can click the raw, it will give me a raw version. Or I can even, online here, I can make changes myself, create a new commit message, and commit a change. Now, as well here, if we go under the network option, we can show the little history graph we've been building up. And again, since I only pushed the master, all it knows is about the 2 changes to master. It doesn't know about the changes we added when we added the MPI branch. All right. So let's move along here now to the last little bit I wanted to show you. And that's going to be bringing these 2 versions together. So let's say we're back on our master branch here. Let me see what our status is. Oh, we're on the MPI branch. I want to be on the master branch. So I'll switch back over to the master branch. And One problem with this here is I've got it all nicely broken up into this little function it's exporting. But if I run Python and I import my code as a library, it actually prints hello world, where all I really want is to get access to this greeter function. So in order to support using this as library, I have to basically not only run the main bit if I'm actually the main program. So if my name is main, this is sort of Python stuff, then run greeter. Otherwise, don't do anything. So now, if I run the program from the command line, hello.py, I get the hello world. If I import it into another Python application, I don't get anything, but now I can call the greeter function. All right, so another change I've made here is I've made this program appropriate for using as a library. So let's add that, stage this up. We run the git status. You can say, oh, I've modified the hello py file. It's a PYC file created by Python, byte compiled. There's a git ignore file you can create that tells it, you can tell it to ignore these. So let's just add hello.py, and then we're going to commit the change here. Maybe this one's a little more complicated, so I might actually give a bit more description of what actually I had done. There's an example. Commit it. And now here we are. Now let's have a look at the log here. I've been running these, so we're going to run the one-line log and the graph, and now you're going to actually all right, sorry, let me update my picture here. It's just showing the history of my current version. So what do we have on our picture here? Well, we've got another version. Here, we'll just draw this in. Except for it's sort of off to the side, right? Because it's not my MPI version. So we've got another version here. And this version here is appropriate for making it appropriate for using as a library. Just push this over here. This is the master version we're running on, so master is now up here. And the history of this version here is it comes down here. It goes down here and then across. So we have two versions branching out from this function. We have the master version, which has the library support, and we have the MPI version, which does not have the library support. Now let's use our final git command here. So we can do a push. We can push that up again if we want. We can say push to origin, the master branch, so we can let the GitLab server know about it. There we go. That'll have updated that. And I'm not going to actually have time to show you, but the command to pull down on the other side, I'll just put it in here for completeness, is fetch. And it's the same. It's a remote followed by a branch. All right, so the final thing I wanted to show you was bringing these two bits together. So in other words, I like this library work that was done on the main routine. I like where it's gone. I want to bring that into this MPI version I want as well. So to do that, I'm going to do a git checkout. I'm going to switch back over to the MPI side. And then I want to merge in the work that's been done on the master branch. So pick up this library thing. And the command for that is perhaps not unsurprising, git merge. What do I want to merge? I want to merge the master work. Let's just reload the hello.py here. You can see this is the MPI version, git merge master. Okay, so it's asking me for a description of what I did, merge branch master into MPI. Maybe we can come up with a better description like that, but I'm not going to. And there we go. So merge made by recursive strategy, one file change, two status. So there were no errors, there were no problems. And what it actually does is it looks through all the files, and so long as you just edited different parts, then it brings the latest bit from each of them. So if I reload this hello file here, you will see it's brought this was the latest stuff on the MPI side here for the actual greeter function, and the latest bit for the actual call to the greet function was on the library side, where we wrapped it with the check on main. Back over on this side here, we've created yet another version up here, which we'll just call MPI plus library. And it comes from here, and it also comes from here. And my MPI stuff has moved up to being that one. And now if I run the git log command, git log, this now the actual history is a bit interesting. So we'll do a one-line log, and we'll show the graph. Then you can see it's showing exactly what it says. Well, I showed it on the left, it's showing it on the right. So we've got the merge, we've got the library loading stuff, which was done on the one branch. We got the multiprocessor source that was done on the other branch, and both of those branches came from the modularized version of the code. So, and then maybe now I'm actually happy with it, so I can say, okay, now I'm going to push the MPI branch up to the GitLab server. Again, my username and password. There we go. Go over to the GitLab server. Have a quick look here, refresh this graph. There you can see now it's showing the full sort of history there with that branch in it. And if we go back to our files, now we can look at the master version, or we can look at the MPI version. So I think I'm just going to leave it there. That's been the full hour. I was hoping to get a chance to log in with another user and show how they can interact as well. But I think that's a pretty good point. Actually, I might add just one more little detail here. So I've showed fetch and push. So fetch I can use to bring down changes if the other version's ahead of me. You'll often see people refer to a pull. So what is a pull? A pull is simply a fetch followed by a merge. So it fetches, brings down the latest version, and then it runs the merge to bring it in. I'll just add that down to the bottom right here. So if you see this here, pull, and again, that's the remote. And the branch. And what is that? That's just simply fetch plus merge. Exact same thing as if you had ran fetch yourself followed by merge. What's the syntax for the merge? Well, it's just merge commit. All right, so I hope maybe this has, there's our Git story. I hope you can see it's not actually scary. There's a lot of commands, but I guess that sort of results from there being 4 parts and you're just moving stuff around between them.